Picture this. You're trying to build a massive, towering skyscraper without a blueprint. You've got all the steel, the glass, and the construction workers ready to go, but literally no one knows how tall the building should be, where the elevators go, or if it even needs a parking garage. I mean, it would be total chaos, right? Well, building complex software without establishing your requirements first is exactly the same thing. Welcome to This Explainer. Today, we're focusing squarely on day 2 of system design, and we're talking about the absolute foundation of any successful architecture. Because before a single line of code is written, we have to draft our blueprint. Okay, let's dive into this. Requirements engineering. This is the crucial foundational step of day 2 in system design. Think of it as the ultimate planning phase. This is where we sit down and rigorously define the system's capabilities, its performance goals, and its hard limits. We aren't just guessing what the software should do, we're engineering the exact specifications of its reality. It's about answering the critical questions early, so you don't end up having to tear down the walls of your digital skyscraper halfway through construction. Here's our game plan for today. We'll start with the blueprint, then break down functional versus non-functional requirements. After that, we'll define our users and use cases, map out our constraints and assumptions, and finally, we'll tackle the art of trade-offs. Section 1. The blueprint. Requirements engineering. Our goal today is to take the incredibly abstract concepts of software planning and completely demystify them. And to really master these steps, we aren't just going to look at them in a vacuum. We're going to apply them directly to a practice scenario. We are going to design the requirements for an e-commerce system from scratch. Whenever you're trying to understand system design, tying it to a real-world application, like a massive online store, just makes everything click into place. So keep that e-commerce store in the back of your mind as we walk through these 4 primary steps. Section 2. Functional versus non-functional. Features versus performance. And this brilliantly illustrates the very first major hurdle of our e-commerce build. We have to separate what the system actually does from how well it does it. Take functional requirements. These are the literal features. It's the what. In our e-commerce system, a functional requirement is that the system must have a checkout cart. If a user wants to buy something, they need a cart to put it in. It's binary. It either exists or it doesn't. But then you have non-functional requirements. This is the how well. It's not just about having a cart, it's the fact that this cart must load in under 1 second, even when 1 million people are rushing the site during a massive Black Friday sale. It dictates the performance, the reliability, and the sheer scale of the feature. Just imagine this for a second. What actually happens if you only focus on functional requirements? Say you build an e-commerce store with the most beautiful checkout button in the world. Functionally, it works perfectly. But because you completely ignored the non-functional requirements, it takes 5 entire minutes to process a single payment. I mean, how many customers are going to wait around for that? Exactly 0. This is why both sides of the coin are absolutely vital. A feature is completely useless if the performance metrics make it inaccessible. Section 3. Defining users and use cases. Who is actually using the system? So, a beautifully functioning, highly performant system is entirely useless without the actual people logging in to use it, right? Let's look at the populations living inside our e-commerce world. We don't just have users as some vague single entity. We have different actors, and each one interacts with the architecture in vastly different ways. We've got the shopper, who's browsing and buying. We've got the admin, who is maintaining the site, handling disputes, and overseeing the platform. And we have the seller, who's uploading products and fulfilling orders. If you design a system thinking only about the shopper, your sellers won't be able to list their items, and your entire store falls apart. Each actor requires entirely different features and pathways through the software. This is exactly where use cases come into play. A use case is simply mapping the specific journey of every single actor. For our shopper, their use case is seamlessly searching for a product, adding it to the cart, and securely paying. It needs to be totally frictionless. But for the seller, their use case might be securely managing inventory in the background, analyzing sales data, and printing shipping labels. By defining these use cases during day 2, we ensure our blueprint actually accounts for the day-to-day realities of everyone involved. Let's move to and see how this builds into Section 4, Constraints and Assumptions, the Reality Check. Now, what's really interesting about this slide is how we organize these parallel design concepts. This is what I like to call the reality check of system design. It's where we explore the boundaries placed on our build by time, money, and simple physics. First, we have constraints. These are your hard limits. Maybe your startup only has a limited server budget, or you're up against a strict 3-month deadline before the holiday season. You cannot negotiate with a hard constraint. You just have to design around it. Then we have assumptions. These are the things we believe to be true to make our design work, but they aren't guaranteed. For instance, we assume our third-party payment gateway won't crash. We also assume users will patiently click buy just one time. Though, let's be honest, we all know the moment there's a millisecond of server lag, a user's going to angrily mash that buy button 50 times in a row. I absolutely love this quote because it sums it up perfectly. Constraints dictate what you can build, assumptions dictate what might break. Constraints are the known, documented borders of your map. They dictate what you can actually build with the resources you have today. Assumptions, however, are the hidden, undocumented risks. If your assumption about user behavior or third-party reliability is wrong, that is exactly where your e-commerce architecture is going to break under pressure. You have to clearly list both of these out in your blueprint so you know exactly where your system is most vulnerable. Section 5. The Art of Trade-offs, the Architect's Dilemma. This brings us to the climax and resolution of our Day 2 Masterclass. This is the ultimate dilemma for any system architect. Here is the harsh reality that every great engineer just has to accept. In system design, you simply cannot have it all. When you try to balance those functional needs with intense non-functional demands while staying within your budget constraints and guarding against your assumptions, sacrifices must be made. An architecture that prioritizes one metric will almost always do so at the expense of another. So, the crucial point is really about making the right choice for your specific situation. Look at this classic trade-off. On one hand, you have perfect accuracy. Every single transaction is rigorously checked and double-checked against the database. But the cost? Slower checkout processing. On the other hand, you have lightning speed. The system moves so incredibly fast that customers never wait, but the cost is occasional inventory sync delays, meaning you might accidentally sell an item that just went out of stock a millisecond ago. During a massive flash sale, an e-commerce site might actually have to choose that lightning speed just to keep the website from crashing, even if it means apologizing for a few double-sold items later on. Requirements engineering isn't just about making lists. It's about making really tough decisions before the coding even begins. It's about knowing your blueprint inside and out. So I'm going to leave you with this question. When you're architecting your next big project and the pressure is on, will you trade speed to ensure perfect accuracy? Or will you sacrifice a little bit of accuracy to guarantee lightning speed? The choice is yours, but you have to make it now. Thanks for joining me in this explainer on Day 2 system design, and I highly encourage you to keep exploring these foundational concepts.